going somewhere new and only have one spacecraft and one chance.
NASA's New Horizon voyage to the planet Pluto.
This is exploration at its finest.
A decade-long journey.
You gotta want it. You gotta really want it. The suite of instruments is really unparalleled.
To the ragged edge of our solar system.
What's out there to be discovered? There are always risks. It's the unknown that will get you.
I just want to see what's that.
To encounter our most contested planet.
I knew something was going to have to change.
I remember thinking, nobody cares about Pluto.
What would it be like to be standing on Pluto? What would a year be like?
We're going to be the first people to see this ever. What do you mean when you say the word planet?
There's no other word for what you call something like Pluto.
This is the telescope that started it all.
It really was an accident of history.
I would like to call for a vote.
I think the decision is flawed.
We're going to show them Pluto really is a planet.
The only prediction that I'll make is that we'll find something wonderful.
What we're seeing truly is wonderful. This is an alive place. There's evidence of geological activity, smooth areas, ice mountains. It's nothing like we imagined it would be. And this is only going to reignite that emotional debate over whether Pluto should be considered a planet. And the whole world's looking right now, but we've been following this team for months, watching them plan every last detail for an epic journey to the unexplored frontier of our solar system.
I think New Horizons is part of the greatest exploration missions ever launched.
That region of the solar system is today our Wild West.
We're the pioneers. For the first time, seeing what Pluto really looks like. To go to the Kennedy Space Flight Center on January the 19th in 2006.
We have ignition and liftoff of NASA's New Horizons spacecraft on a decade-long voyage to visit the planet Pluto.
To see this huge rocket launching our little spacecraft on the top, weighs about 1,000 pounds, we get 1,000,000 pounds of thrust.
And boom, that rocket's up and gone and on its way.
Let's talk about speed. 16,000 meters per second at 36,000 miles per hour. Fastest thing ever launched from the Earth.
45 minutes, it's over the Indian Ocean. 9 hours later, we'd already crossed the orbit of the moon. This is the fastest spacecraft ever to leave the Earth.
We're traveling so fast that we would go from LA to New York in 5 minutes, and we do that 24/7 for 9.5 years. That's what it takes to get to Pluto.
The furthest planetary destination ever attempted, to the outer edges of the solar system. A tiny spacecraft hurtling through space at epic speeds, facing unknown dangers. One shot to capture this planet up close with high-resolution cameras for the very first time.
This exploration is the pivotal piece in coming to understand how our solar system came to be and to look like it is.
It gives us so many clues about where the solar system came from, how it got to be here, that you just can't pass up an opportunity to study a place like that.
Getting a green light for a mission to seek those answers wouldn't be easy.
It was a challenge, you know, it took over a dozen years and many attempts by lots of people who were working very hard to get approval to start the mission. We had to build an outer planet spacecraft in record time. We had to get nuclear launch approval in record time, get a new launch vehicle qualified, and produce this very sophisticated, never before been built suite of scientific sensors from scratch.
Built to rocket through space, endured temperatures 3 times colder than anything on Earth, and to protect its prized cameras, which will give us the only close-up glimpse of Pluto.
So we had to be lean and mean, but also really high-tech.
They weigh just less than 50 pounds, 30 kilograms. That's amazing.
All 7 instruments aboard New Horizons and their flight microprocessors draw less than half a 60-watt light bulb in power.
We had to do that because Pluto is so far away, we couldn't have big giant solar panels. The sun is too faint, 900 times fainter out at the distance of Pluto.
Without sun, it would need power. They would pick, of all things, plutonium. But to get there in record time, they're counting on a supercharged slingshot from Jupiter.
We would save 3 years. That's a lot on a 9.5-year flight time.
We're stealing a little momentum from Jupiter, increased our speed by 20%.
Now 24 kilometers a second, 50,000 miles per hour. They have a chance to test their cameras. They make an amazing discovery flying past Jupiter's moon, Io.
We did not realize that essentially the largest volcano that anybody had ever seen would be coming off of the North Pole of Io.
There was a black and white image, and you can see the plume erupting from the surface. And then we had a color image of the same thing, and you could see the hot spot and the different color of the plume erupting. So it was very satisfying.
Spacecraft is outward bound from Jupiter, and we're on our way to Pluto.
Pluto, still distant, 8 years away. The team uses the spacecraft's cameras to help navigate the long journey, watching for any hazards that could be a threat. But what they find is something unexpected.
When we launched the mission, we only knew about 2 objects. We discovered 2 more very small moons. Pluto is like a little solar system. It's amazing. There are a total of 6 objects, known objects, in that system.
Pluto, its main moon Charon, and 4 others.
So that begs the question, well, we found these. What else is out there?
It's very hard to put another moon in this region because it's a chaotic system, and if you throw in another moon, it'll get tossed out of the system eventually. The system is very close to the edge of stability. On the other hand, Pluto has always proved us wrong. Every prediction we've ever made, it's proved us wrong, and I look forward to being proved wrong once again.
As we're getting closer to Pluto, what are the effects of having all of these small moons? And what if we discover new moons during the approach?
That approach is now. Things could get dangerous.
Go ahead, GNC.
We're actually going to try and speed the spacecraft up a bit so that we reach Pluto at the right point in the orbit at the right time.
We have spent 8 years crossing the entirety of our solar system. We are now in the place this spacecraft was built for.
We are worried about hazards. They are a possibility.
At the speeds that New Horizons is flying through the Pluto system, just one little dust grain hitting the wrong spot on the spacecraft, it's game over.
We don't want that to happen.
It's game time.
So it's a high-stakes game that really has paid off, and for no one bigger than Alan Stern. You're the PI for this mission. So tell me, is this the Pluto you've been imagining?
It's better than the Pluto that I imagined. You know, the Pluto that I imagined was in a video by the National Space Society that was just released about a month ago. And we went about as far out on a ledge as we could. But the range of geological expression that we're seeing, the number of different surface units that tell us that this world, as small as it is perhaps as complicated as the Earth or Mars, is blowing our minds.
And so after 10 long years of waiting to finally get there and to have this moment go by, what has this experience been like for you, this flyby?
It's been absolutely incredible because it was like an accelerating roller coaster the whole way. As we got closer and closer, we could see more and more detail. And now we've captured these data sets that are going to allow us to unravel the entire history of the planet and the history of the system.
Well, you've got a lot of work ahead of you. Congratulations on a job well done. Fantastic.
Thank you very much for the whole team.
And as the data come in, we start to see the answer to the big question, why Pluto?
We're going to where no one has gone before to see something completely new, very alien, beyond human experience.
There could be mountains, there could be valleys, there could be impact craters.
One of the things I'm really holding out for is volcanoes.
Pluto or Charon could be dead, or they could be alive, or they could be very alive.
For much of my career, I've tried to figure out just what Pluto looks like.
It's been a mystery. A blurry, bright spot far in the distance, Pluto is now coming into focus like never before.
But never really fit into the family of planets from day one. It was always a much smaller object than the 4 giant planets or the 4 interterrestrial planets.
It's small and round. In fact, 6 Plutos could fit on Earth, and it's been classified as a dwarf planet. A pretty new category for the rocky ice spheres who aren't hefty enough to clear what floats around them.
Dwarf planets are planets too, and there are really more dwarf planets in the solar system than there are, quote, regular planets.
Pluto lives on the edge of the solar system.
The draw for Pluto is the concept of the frontier.
Pluto was just the tip of the iceberg. There's a whole family of objects out beyond Neptune's orbit in a region called the Kuiper Belt. That's a region that we haven't explored, and it turns out by studying the small bodies of the solar system, they give us a window back in time to what the solar system was like when it first formed, when the planets first came together.
It's freezing.
And the surface of Pluto is only about 400 degrees below 0 Fahrenheit. There's no place on Earth that's anything like that.
You'd feel weightless. The gravity is less than half of what they experienced on the moon.
Boy, is this a neat way to travel. Isn't it great?
It's so far out that Pluto's journey around the sun takes 248 years. It hasn't even made half an orbit since its discovery in 1930.
And also, instead of traveling around in a circle, it's in a highly elongated, what we call an ellipse, an egg-shaped orbit, which is also unusual relative to all the other objects out there.
And moons, there are 5. The 4 small ones tumble in chaos, while the biggest, Charon, faces Pluto at all times. But it's Pluto's surface and what could be lurking below that has everyone on the edge of their seats.
What does Pluto really look like? Does it have mountain ranges? Does it have valleys? Does it have geysers on the surface?
Certainly there's a lot of ice, but we do know already from Pluto's density that it has to have a lot of rock mixed in there as well.
Dan Durda has imagined it both as a scientist and an artist. He's the one who's helped us visualize Pluto for all of these years, waiting for new horizons to get close.
We know we're going to be surprised. That's the fun part of exploration. What I'm particularly excited is to see from New Horizons how the actual geology of the surface corresponds to these color and brightness patches that we've been seeing. We know it has an atmosphere. It's a very thin atmosphere, but will there be haze layers? Will it be almost like the Earth, a thin blue line, but much fainter because the atmosphere is thinner? Maybe there'll be some sort of interesting tectonics there, some fault lines or canyons that imply activity.
No one predicted river valleys on Mars or that there would be volcanoes across the outer solar system. We're going into the unknown to make those first discoveries. We're not just going to be rewriting the textbooks. We're going to be writing those textbooks for the first time.
Coming up, if you think this is exciting,
he could tell by the tone of Dad's footsteps that something important was going on.
Imagine what it was like when an American first discovered Pluto. This is the image released by NASA just at the moment that New Horizons is at its closest point to Pluto. And just look at it. There's a heart right in the middle of it. This picture has gone viral around the world. It's amazing for everyone, but especially for the Tombaws, because their dad discovered Pluto.
Oh, it's elation. Just total elation and David.
This is the telescope that started it all. Dad's 9-inch reflector, the mirror of which he ground in 1928, and it started the discovery of Pluto.
Frequently, I would get called out of bed to come see something interesting out in the backyard.
I'm Al Tombaugh. I'm Clyde's son.
I'm Annette Tombaugh, Clyde's daughter.
Their dad, Clyde Tombaugh, discovered Pluto in 1930. How he did it was nothing short of amazing.
He grew up in the Depression era, so he understood that you had to make use of whatever you could get a hold of. So he used whatever he could find to incorporate it into the telescopes that he built. A lot of the parts that he used to build this came from old farm machinery, such as the flywheel off of the tractor, an axle off of a 1910 Buick. The tube came from some equipment they used for shuffling grain into grain elevators. He used everything that he could and had a quite ingenious way of putting everything together to work. This telescope, as Dad said, it was the best one that he ever constructed.
Observations from that telescope landed Clyde a job at Lowell Observatory in Flagstaff, Arizona. At just 23, he became part of a quest to find Planet X.
There was a vision here that was all about the next planet out beyond Neptune.
He helped with the maintenance of the observatory, particularly keeping snow off of the roofs and the domes. Then they started in working with the 13-inch.
That was a very good telescope.
There's nothing like that in the world. You're headed to the telescope for your time to go study the skies. You've just had dinner, the sun's going down, the sky's getting dark. What are you going to find tonight? Am I going to find another planet?
Mark Bowie's walked this path hundreds of times. In many ways, he's followed in Clyde's footsteps.
You have to load a big glass plate into the back of the telescope, point it in the right place in the sky to collect the light. You might expose this plate for an hour. You're standing in the dark, in the cold, and looking through this little eyepiece to make sure the telescope perfectly tracks the sky.
Like snapshots, he'd steal a glimpse of the universe night after night, then investigate every little dot.
There's just gazillions of stars to look through. Your task is to find the things that are moving.
To do this, two plates are lined up side by side.
You compare them, you see one then the other, one then the other, one then the other.
And you just keep doing this over and over and over again.
Eventually, Tombaugh saw something move.
He could tell by the tone of Dad's footsteps that something important was going on.
Yeah. He was elated that he was the only one on Earth that knew there was another planet, but he also was pleased that he could satisfy what his employers wanted.
The first planet discovered by an American.
I don't think they realized the amount of press they were going to get. I think it changed him a great deal.
He never wanted fame. He wasn't someone that would have followed that line.
This is a piece of history right here. There's a thread connecting this glass plate to that spacecraft hurling its way to Pluto right now. And it all started with this picture.
His discovery, a legacy that will live on.
Oh, he would have been thrilled about a mission.
We're going to find a lot of unique things on Pluto. We're going to be so close to Pluto that it would be like playing I Spy from the satellite around the Earth on New York City.
And he would have found that absolutely exciting.
He would have loved it. Just loved it. He would have loved to have been on the science team. I would love to be on the science team.
In a way, Clyde is on that team. Some of his ashes are aboard New Horizons.
Well, it's great that we were able to cast their ashes on the winds here, and now part of Dad's ashes will be cast on the solar winds of Pluto.
Still ahead, the 9th planet is ousted.
I am perfectly happy to be known as the Pluto killer.
A controversial vote changes everything.
Those are astronomers. Why the heck are they deciding what a planet is?
So if you look at this computer animation of the New Horizons spacecraft as it goes through that flyby, you can see how much it has to rotate and dance around to collect the data, not just from Pluto, but from the other moons in the system as well. And those images are finally starting to come in, and they are creating a ton of buzz. Buzz that is inevitably going to lead people back to that question about what Pluto's status should be in our solar system.
Right now, we're heading up to the summit of Mauna Kea. Mauna Kea is the big volcanic peak on the big island of Hawaii here in the middle of the Pacific Ocean, and it's one of the best spots in the entire world to do astronomy.
Mike Brown is known for traveling to majestic summits to hunt for planets.
And on top of Mauna Kea are many of the best telescopes in the world, and the Subaru telescope is the premier telescope for discovering new things in the outer solar system. It's clear, not a cloud in the sky above here. It's going to be a spectacular night.
He's looking in the furthest reaches of the solar system, where Pluto lives.
Understanding how they got there and understanding what they're made out of is one of those keys to understanding how the solar system really put itself together.
Working through the night, maybe he'll find something new. It's happened before.
We really never knew when we were going to find the big ones versus the small ones versus anything else. So it was totally random. I had no idea the morning that I went in that I was going to find what became Eris. It was a morning like any other morning, and suddenly there it is on the screen in front of me, and I knew we were onto something.
He discovered Eris, a planet about the same size as Pluto, but further out in the Kuiper Belt. Eris takes 557 years to make a trip around the sun. Its discovery, and the likelihood of more planets like it, sparked a fiery debate and earned Mike the title Pluto Killer.
The discovery of Eris was a couple of weeks before New Horizons launched.
Less than 10 minutes, we should see the liftoff of our New Horizons spacecraft toward the planet Pluto.
I remember the announcer at the launch says, well, it's the mission to the last unexplored planet. And I said, well, that's not going to be true by the time it gets there, because you knew as soon as you discovered Eris that either it was going to be a planet or Pluto was not.
I would like to open this IAU General Assembly.
The General Assemblies of the International Astronomical Union happen every 3 years. We have scientific discussions, and occasionally there are topics that come up which are a little more interesting, such as what is the definition of a planet? My name is Gerard Van Bell. I was one of the astronomers actually at the vote in Prague in 2006, where we voted on the status of Pluto and other bodies in the solar system.
Astronomers, not planetary scientists, would determine the fate of Pluto. Just 5% of the total membership would actively participate in this historic vote.
There was a certain electricity in the air because we knew that whatever came out of that meeting was going to make history.
First of all, those are astronomers who mostly study galaxies. Why the heck are they deciding what a planet is, okay?
A dwarf planet.
I've never been to an IAU meeting. I'm not an astrophysicist. I'm a planetary scientist. I don't go and look at their galaxies and say, this is a galaxy, that's not a galaxy. So why are they saying what's a planet and what's not a planet?
We originally hoped to be able to define planet more widely, but we found it too difficult to manage appropriate wording.
They came up with a definition that was just way too complicated. It was crazy. Not only did it have to have the definition that most of us agreed with, which is that the body had to be massive enough to naturally form almost perfect sphere, but it also had to be massive enough to clear out its neighborhood in space.
So when a planet goes around its orbit, does it clear its orbital zone? Does it push everything else out of the way?
Right now, I think there's confusion. John?
I was watching from half a world away, and I came out very forcefully and said, look, you're not just debating Pluto, you're debating Eris and all of these other objects. These are small bodies flitting around the solar system. These are not some of the large, grand, important bodies of the solar system. And as much as I would love to be a person who has discovered planets, it just doesn't make sense. Eris should not be a planet. Pluto should not be a planet. None of these should be planets.
It would be disastrous for astronomy if we come away from the General Assembly with nothing. We will be regarded as complete idiots.
Thank you.
It was all very rushed, I think.
I would like to call for a vote. Those who are in favor of Resolution 6A.
With only a fraction of the assembly in attendance, a resolution is passed with fatal implications for Pluto.
I think the decision is flawed. I certainly do stand by my vote still, which would have basically kept Pluto as a planet.
I'm a little sad that the science got lost in the emotional debate. But as scientists, we have to take that part away, and we have to just look at the solar system as it is, and no one would ever classify Pluto as a planet.
Well, we just fundamentally disagree with that definition of what a planet is. We're going to show them as we fly by, after we get our first really great pictures, and we'll say, you see, Pluto really is a planet.
So Pluto may have been kicked out of the Planet Club, but if you look at all the people who showed up for this event, it's clear they're not going to let Pluto go anywhere. It's safe to say there's still a lot of Pluto passion.
Welcome, everyone, today.
Hundreds are here to show their support for the once ninth planet.
Pluto will always be a planet for us.
And there's no bigger celebrity for this crowd than the mission lead for New Horizons, Alan Stern.
That's a great question, by the way. The people here have been putting this on year after year, and this is the year of Pluto. Lots of anticipation. After all these years and all these miles, you gotta pinch me, we're really here.
Okay, we're going, let's go! We're number 9! We're number 9! 2, 4, 6, 8! Pluto is really great!
Pluto has always been very popular, especially among kids, because it's like the runt of the litter. It's very small, and it doesn't get any respect.
People are very excited about Pluto, poor little Pluto. There's a personal affection. I don't know why, but, you know, it's a fun planet that people love.
There's also the fact that it is the only planet discovered by an American.
In 1930, Clyde Tombaugh made that discovery. He was no longer here to see its status change, but his daughter remembers.
Stunned is your reaction. It created a very strange feeling, like, you know, you'd hit an air pocket on the plane. All of a sudden, the textbook companies were scrambling to take Pluto out of their astronomy sections.
So you have all these products that had been in classrooms on collector's shelves that put Pluto into a class of objects it no longer was.
Rob Perlman knows a lot about space collectibles. He's always searching for that it item, and he's very interested in the Pluto problem.
If there's one thing collectors like more than anything else, it's mistakes. The idea of a stamp printed wrong, a coin struck wrong. Now you had all these products that were just mistaken. It was not a planet at all. It was a dwarf planet. Now you had the Pluto going out of business sale. So you would have the before and after, and suddenly a new type of collectible was born.
The economic effect? Millions. Toys, books, mobiles, all needed to be changed. Or did they?
Icy Little Pluto is still a hot product in the stores. 9 years after its demotion, it's still being included in solar system models, in toys, in puzzles. That's because that's what the public wants. They want Pluto as part of their solar system.
A lot of people here would buy into that.
What do we want? Equal recognition of dwarf planet! When do we want it? Now!
I understand the people who protested the reclassification. It's hard to lose part of your childhood. This was everybody's favorite little underdog ninth planet for so long, and there's an emotional attachment to it. But as scientists, we have to take that part away.
Regardless of its label, Alan Stern is focused on the bigger picture.
It's very important to me personally that we do what the adults of our parents' generation did for us in opening up the solar system for the first time and enthusing so many kids about exploration and science and technology. We have an opportunity to show as an example how much fun this can be, how enlightening it is, how great the scientific chase is, so that they can take on even bigger challenges.
Up next,
we know we only have one shot at it.
looking through the lens of New Horizons.
We're going to be the first people to see this ever.
Capturing images like these while watching for dangers like this. This is your spacecraft. This is New Horizons. We're actually backstage at NASA where their 1/8 size model is. This is the plutonium power source. You've got an antenna that has to point towards Earth to send data. But the collecting of data during flyby happens with a great camera that is right there. It's called LORRI, and its story begins in the backyard of an avid stargazer.
We're here in Gamber, Maryland, in my backyard observatory. I've been an astronomer since I was 12 years old. It was like the sense of discovery. It's like I found something I didn't know existed. When I was a teenager, I started building my own telescopes. I was grinding my own mirrors and building my own optics in my basement. I found out that building them was just as much a passion. Well, that's how I got into my profession.
Steve builds cameras. As the engineer behind the LORRI imager on New Horizons, he's playing a part in revolutionizing space history.
I was responsible for overall building, assembling it, testing it, calibrating it.
LORRI is a digital camera with a large telephoto lens. At closest approach, it will snap 450 photos of a planet never seen before. It will reveal things like craters and cliffs.
We were given the requirement that when we were at closest approach to Pluto, about 10,000 kilometers from Pluto, we could resolve about a 100-meter object. The Central Park's a great analogy. If we flew by the Earth and we were imaging Manhattan, we'd be able to make out the ponds in Central Park in New York.
But building a camera to withstand minus 400-degree temperatures isn't easy.
Telescopes are not very well behaved when they're in a challenging thermal environment. That caused us to have to use special material, which is silicon carbide.
It's the same material that's in bulletproof vests.
Silicon carbide expands and contracts very little bit with heat and temperature.
That's key because it needs to stay in focus. Every step of the way, the imagery from LORRI helps the flight team stay on target and is critical in detecting potentially mission-ending hazards.
LORRI is a fixed focal length camera. We can't adjust it. So how we focused it on the ground is how it has to be in focus in flight. So the distance between the primary mirror, which rests here, and the secondary mirror, which is here, has to be maintained very precisely. Because as we go by Pluto, we only have one chance to get our best imaging.
They're counting on this glass to reflect when there's hardly any light.
Pluto is 30 times further from the sun than the Earth is. In order to collect those few photons that are bouncing off Pluto's surface and arriving at the New Horizons spacecraft, we need a large collecting area to maximize how much light we get there.
Until this year, the best look at Pluto came from Hubble. A week from Encounter, Pluto looks like this. The images continue to pour in.
I thought it would never happen. You know, when we launched, we were over 9 years away from Pluto, and 9 years just seemed like forever. We're going to be the first people to see this ever, and it's coming from an instrument that, you know, I was part of the team that developed. It's just amazing.
Coming up,
it is surprising what a small particle can do to spacecraft.
Dodging mission-killing hazards.
We temporarily lost contact with the spacecraft.
If you can't talk to it, you can't rescue it.
Space is mostly empty. But when you get close to a planet like Pluto with 5 moons, anything could be floating around.
A little dust particle can smash a hole in the spacecraft and destroy it. There's so much energy.
Hal Weaver knows this threat better than anyone.
He's one of the early architects of this flyby. As the spacecraft approaches Pluto, he's ready for the potential of hazards.
We've picked out what we think is the safest possible trajectory through the Pluto system. We think that the odds are very, very low, less than 0.1% chance that we will have to divert the trajectory. The last couple of weeks are going to be the scariest.
After nearly 10 years in flight, that time is now. The team is gathered to make one of the most crucial decisions of the mission.
This weekend is our last chance to make a change to the spacecraft's trajectory in a relaxed manner to avoid any of these new hazards.
Over the next 3 days, the team will pore over images taken from cameras on board, looking for mere specks of dust that could be mission killers. They know because they've tested this threat in the lab.
It is surprising to see what a small particle, something even a marble size or smaller, can do to spacecraft. My name is Kevin Foreman. We're at the University of Dayton Research Institute, and I fire projectiles extremely fast.
Here, the most critical parts of the spacecraft are put in the line of fire.
You're one of the few facilities in the U.S. that can launch particles to simulate this dust that can threaten the spacecraft. So with New Horizons traveling nearly 14 kilometers per second and dust in space traveling upwards to 30 kilometers per second, that could create a devastating impact on the spacecraft.
It's why the team back in Maryland needs to be sure nothing is in their way.
It's very tense right now because we don't have all the time in the world to look at this data as it comes down. We've got to make decisions.
They need to decide whether they'll stick with the planned flyby or take a new route. Right now, the plan is to get nearly 40 times closer to Pluto than the Earth is to our moon. Sensors will probe the solar wind and measure the atmosphere.
If we do decide to change the trajectory, it's going to really hurt the science return that we get back from this mission.
To avoid obstacles, they could fly closer, but at those speeds, the images could blur. They could also turn the spacecraft and use the antenna as a shield, but that would mean its instruments would be turned away. Crucial data lost.
We'll do that if we have to, but this is the time that we make that decision.
This team has been working really hard to determine if there's any dangers along the way. They're going to present their results, and NASA will make a decision based on that recommendation.
Within no time, a decision is made.
So we're going to gut it out. We're going to stay on the trajectory we want.
The Pluto system is just clean as a whistle. And we can't find any more satellites. We can't find any rings.
It's hard to believe after, geez, it's been almost 3 years, 2.5 years we've been working on this hazard stuff. I felt like, wow, it's finally going to sink in that, you know, we're on the nominal path and everything is cool. But now I'm just so tired.
The coast is clear. Countdown is on. Just days before encounter, something unexpected happens.
We temporarily lost contact with the spacecraft.
It's about the most serious thing that can happen, really.
It is sort of a hollow feeling when your spacecraft's not talking to you.
If you can't talk to it, you can't rescue it.
New Horizons' computer hits overload. It stops collecting science, it stops navigating, it goes into safe mode.
It was an instance of the machine being tasked with too many things at once.
Everybody just went into action. People went back to their offices, got whatever they needed.
I went immediately over to mission control.
We all knew what we needed to do.
They have to reload the flyby command sequence to the spacecraft. Their biggest hurdle is time.
Once you radiate that solution to the spacecraft, you've got to wait 9 hours to hear back from the spacecraft. I did that, and here's what happened.
People did not want to go home. They wanted to be here with the spacecraft and to watch every part of the recovery. So we were taking little naps in between the work that we were doing.
They send multiple commands to get it back on the flight path. Then they wait.
So that's going to be a huge sigh of relief when we see that load starting, because now we know we're into territory that we've tested over and over again.
Pluto Mom, this is Pluto Ace on Pluto 1. We can confirm the first time tag is fired.
Copy that, everybody. We're now in the flyby sequence.
To address that anomaly in only 2 days, simply amazing. You know, so I can't be prouder of the team.
Still ahead, back on track and ready to reveal an exotic world.
Pluto is very much the Everest of planetary exploration.
Never seen like this before.
This is exploration at its finest.
We've recorded the expected amount of data.
Oh my God.
Copy that. Looks like we have a good data report.
A flawless flyby of Pluto and its moons. Hundreds of images taken at close range, now streaming back to Earth. Now, it's going to take more than a year for us to get them all, but as each one rolls in, we discover more about this mysterious world.
We have a healthy spacecraft. We've recorded data of the Pluto system, and we're outbound for Pluto.
This is payday.
It's fascinating. What we're seeing is looking really exciting from a few pixels across.
Pluto becomes a real world.
This is in the history books.
It's certainly not a boring old rock.
Pluto has finally revealed its secrets.
We've opened up a new realm of the solar system.
Let's put it this way, Pluto is certainly not flat.
We now see mountains on Pluto.
Up to 11,000 feet high. They'd stand up respectably against Rocky Mountains or other significant mountain ranges here on the Earth.
The bedrock that makes those mountains must be made of H2O, of water ice.
Water ice is so hard at these temperatures that it could support the topography that we need to make these mountains.
This is the first time we've seen an icy world that isn't orbiting a giant planet.
I think it's going to send a lot of geophysicists back to the drawing boards.
We thought since Pluto doesn't have this huge planet next to it, they could tidally heat the interior, that it's going to be very boring.
I can tell you right now that Pluto is not boring.
It's clear that there are seasonal changes.
We had this very bright, exotic snow.
We know Pluto does have an atmosphere. It's nitrogen, just like our atmosphere here.
It's the other red planet. But of course, there are many different hues of red.
We're still learning what those different bright and dark spots mean, but basically they're telling us that they're probably made out of something different.
We now have a name for the heart.
Because it's the brightest and most prominent feature on the planet,
We want to honor the discoverer of Pluto.
we want to informally call it Tombau Regio for the discovery of Pluto.
This is civilization's first step into this whole new region of the solar system.
And that's just the tip of the iceberg.
Pluto is now revealed. Now we have explored all 9 of the original planets. It's a great day for NASA. It's a great day for humanity. And it's not over. That spacecraft is going to continue sending data back from Pluto, and then it's going to travel out past Pluto, sending data from beyond. It's an historic moment. Thanks for being a part of it. I'm Dan Riskin. Good night.